All right, everybody. Welcome to another Ask a Dev Unreal Engine live stream tutorial. Now, this one is a re-record of the live stream we did this morning just to kind of fix up a couple of things that went fun, because something always goes fun in these. And what we are talking about today specifically is decorators and services for our AI, or artificial intelligence ability trees. My name is Kevin. I currently work as a senior principal tech artist at Riot Games. I get to do a lot of cool things. I work in R&D. There's a lot of cool things I don't get to do, and I get to learn an amazing amount doing these for the community. Speaking of community, quick shout out. It's awesome. The community has been awesome. I want to thank you all for being part of it, for watching the videos, helping spread the word, everything that you're doing, even helping me out in the live streams and in Discord, etc. So you all are awesome. I appreciate everybody who's here and for watching the videos. So with that, let's hop into Unreal and kind of recap where we were. And where we were was we had our enemy AIs. They're able to move around, find a target, shoot at each other, and deplete their health. Now, what we want to talk about specifically to start off with is decorators. And if you recall, the decorator is really, it's a condition. And if it is true, then the AI behavior tree will be able to continue and execute everything in that branch. If it's false, it will skip that branch and go on to the next. Our tree, as it stands right now, has two fairly simple sequences in it. We have an attack sequence and we have a patrol sequence. Right now, our decorator is set up in probably one of the most utilized ways, in the sense that it basically looks at a value in the blackboard, which is like the memory of our character. And if a variable is set or true or valid or any number of things, then this condition will evaluate to true and this branch will execute. Now in this case, this condition is can attack. So if I am playing, you'll notice that all of these characters are set to can attack and they attack. If I switch this, if I go back to our behavior tree and I set, rather than is set, in other words, if can attack is set, they attack. If I change this to not set, this is going to fail now, and they are going to run around looking for a place to stand. So just to kind of finish the recap. So now they all are running towards these red locations. They get there, they wait. This is the patrol tree. So with that, let's talk a little bit more about these decorators though, because what we want to do is there's a bunch of, in addition to checking if a blackboard value is set, there are other options here. For example, we can compare blackboard entries, we can check on cooldowns. There's a bunch of different things that we can do. And in that case, sometimes we want to be able to create our own conditions, our own cases. And we can do that by creating a custom decorator, and that's what we're going to do right now. So in our behavior tree, what I'm going to do is I'm going to click on new decorator, and I'm going to choose this BT decorator blueprint base. And we are going to do this in the context of healing. So what we want to do is we want to see if our character is healthy or not. And if they are healthy, they will attack. And if they're not healthy, we want them to go find a health pack. So for right now, let's just start by creating our decorator. We're going to call this BTD for behavior tree decorator. And I'm going to call this check health. Okay. And when we create that, the way this works is, unlike a task, what you have is you have a condition check. So we're going to perform a condition check for our AI. And what happens is when this gets evaluated, if the condition comes out as true, just like a normal decorator, then that branch will be able to execute. Or if it's false, it will come out and it won't be able to execute, and it will move on to a different sub branch. Now, there's a little bit of understanding here that we need to have about how our characters are set up. In this case, how do I get the health information from my character? There are many ways this could be done, but today we're going to use kind of like the straight ahead approach. You could use blueprint interface, all kinds of things. But I know, for example, that our enemy has a health component on it. I also know that our base character also has a health component on it. So it doesn't really matter which one it is. what I can do is I can take this behavior tree decorator and I can take the controlled pawn and I could cast this to enemy, or I could cast this to the base character. Either one, it does not matter. And what we're going to do with that is we're going to get that health component. And from that health component, now that we have it, we can get the current health. Get the health. So this value is our character's current health. Now what I want to do is I want to make the decision as to whether or not this character is healthy based on the current health. So if the health is greater than, let's say, 50, okay? Greater than 50. We are going to return true, meaning they are healthy. If the health is less than 50, less than or equal to technically, we're going to return false. The character is not healthy. And this creates our decorator. So here's what's going to happen. If we decide to use this decorator, we've now successfully created our own custom decorator. So let's take a step back and do a dance about that. And then if we want to actually use that, we can right click on our sequence for our attack. And if we go to add decorators, you'll notice that we have this BTD check health. And what's going to happen now in our tree is there's two conditions now that are required for us to be able to do the attack sequence. One is they can attack, and the second one is checking the health. Now, if we check the health and it's good, it's greater than 50, this will be true and we will do this. So what should happen now is our characters should run around and attack like usual. And then what happens is once they hit 50% health, they will stop attacking and start patrolling. Now this might be hard to see. There you saw the first character. That character is now on patrol because they're not healthy. We have one more character that is still running around and attacking because they're still fully healthy. And there's nothing that prevents them from attacking the others. But the bottom line here is you have just successfully created a custom decorator that you can make decisions on in your behavior tree, which is really cool. So let's go back and do a couple things. It's great. They can decide whether or not they can attack based on whether or not they're healthy, but wouldn't it be cool if they actually went and picked up health as a result of our new custom decorator? So to do that, let's create another sequence just for the purpose of learning in context. And this is going to be sequence. Let's do get health, find health. Let's go sequence health maintenance. Sure, why not? Health maintain, sure. And what we're going to do in this is going to be very similar. We want to do this if we're not healthy, for example. So how do we do that? Well, we can take our check health condition, adding our decorator. Here's our check health. And what we can do is we can do the inverse. So over here, if we check our health and it's greater than 50, we're going to attack. Over in our health maintenance, if we check our health and it's not greater than 50, in other words, the inverse of greater than 50 by checking this box, it is going to do whatever is in here. Well, what are we going to do in here? We're going to do a couple things. We need to create a new decorator. Or not a new decorator. We need to create a new task. We're going to create a new task called find health. So I think the easiest thing for us is we're going to take our find enemy. I'm going to duplicate that and I'm going to call this find health. Now we could create a one task true rule them all type thing where we pass in the class, but just for simplicity, let's just change this to find health. We get our owner. We're going to get all actors of class. This is going to be our AoE pad. All right, let's talk about this AoE pad real quick. This AoE pad came from a previous tutorial that we did. And what I'm going to do is I'm going to drop it in our level. I'm going to put it all the way over here in the corner because this is going to help me showcase some of the issues. And the health change amount right now is set to 25. So what this is a healing pad. So what I want when I find health for now is I want to find everything that is an AoE pad. Technically, you would want to actually make sure it's not a damaged version of it because they can have negative, but for now, for the demo. We're going to find it all. Our out actors, we need to change this to be our AOE. I'm going to change that variable type, and it's going to mess up a whole bunch of stuff that we're going to have to reconnect. Okay, so let's just connect that in and refresh the node. That works great for certain aspects of this. It's not going to work for everything. For example, I cannot connect in remove because remove is expecting a specific type. I think I have to recreate that node. Yeah, I don't. So, but actually technically I don't even need the remove because we're not comparing against our current actor. So we have now our AOE pads. This is all of our health pots, if you will. And then what I want to do is I want to get the length of this, because we're just going to pick a random one, just like we did before. So this is going to pick a random index in the size of our AOE health packs. And then with that random index, it is going to check to make sure it's valid. We have to rebuild this one, so just do is valid. We'll disconnect all of this. We'll connect in our random index again. We're just doing some reconnecting. And then with our out actors, let's get okay. Now, we are not going to set our target enemy. We're going to change this. We are going to use our blackboard, and we are going to set a value as vector. And this is going to be the key that we're going to update is our move to location. So effectively, we're getting our character's blackboard, which again, remember, is their memory. One of the memory slots they have is their move to location, and we are going to set that to be the location of our health pot. So this is going to be get actor location, and we're going to feed that in here. And if this is true, if it's a valid index, we are going to set the value, and then we're going to finish our execute. So with that, we have quickly created, we're going to compile and save that. We have quickly created a find health. Now, once we find our health, then as we've done before, we need to move to, and in this case, we're going to move to the target location. Now, this is the part that I want to be specific about. Let's wait here. We're just going to wait for 2 seconds, for example. This is our entire check health tree. When we move to, I want to show you a problem. If I set this move to acceptable radius to 200, for example, what should happen now is as our enemies get down to 50% health, there's our first one. Notice they're running to the health pot. They get there, but they stop before they get onto the health pot. So they never regenerate their health. The reason for that is the move to acceptable radius is too big. So they need to move to this, someplace closer, like the center, for example. In this case, because the actor location's in the middle, and we know the radius of the heal pad is right about 200. Anything less than 200, the character should be standing within that radius. So simply by changing the acceptable radius down to 5, now when our enemies get too weak and they run for health, if they make it there before dying, when they get there, you'll notice that their health starts going up. Great. So then notice how now that the enemy has healed, they are now running around trying to attack again. So they're basically attacking and healing and attacking and healing. And that's all being facilitated by our new custom built behavior tree decorator, which is cool. Now, a couple other things about decorators. There's more in here. For example, you can do things like composite. If you look at a composite, this just takes a bunch of different things as input that you can stack on top of each other. Cooldowns are also fun. There's a lot of really cool things that you can do with it, but now you know how to create your own custom decorators. You might use this for things like finding health packs. That's great. Or not finding health packs, but checking to see if you're healthy, checking to see if you have ammo, checking to see do you have an ability. There's lots of reasons why you might want to make your own specific custom decorator. So with that, what we're going to do is we're going to move on to services. So let's talk a little bit about the example of why we're going to create a service. And a great example of this is you'll see how this, oh, they didn't make it. This character hits 50%. They're running for the health pack. Both of them are running. They never stop to fire along the way. Who doesn't defend themselves as they're running for health? We all do. Well, I think, when we're playing, we do. So it would be great if they would go ahead and shoot as they're running. So run and gun. Here's another example. And this is the one that we're going to start with because it's a more succinct example. You'll notice that as that character chases at me, as they're running, they're not shooting. They don't shoot until they get to where they were going to, within 200 units of me. Why is this happening? This is happening if we look at our attack tree. They find an enemy, then they move to the enemy. Once they start moving to, this does not get complete until they get within 200 units of the target. So attack doesn't happen until they get to where they need to be. Now, if this was a melee attack, that might be great, but this is a ranged attack. Why aren't they shooting along the way? So what we're going to do here is we are actually going to replace this attack with a service. And this is actually where things went fun in this morning's live recording of this tutorial. So hopefully we get it straight this time. So what I'm going to do is I'm going to delete this and I'm going to show you where services work. First off, if we right click on our sequence node, you'll notice just below add decorator is add service. Now currently there's default focus and run EQS. These are a little bit more involved, so interestingly enough, creating our own custom service is actually going to be a little bit easier to understand. What I'm going to do is finish explaining what a service is. When you set up a service, what it is it's something that happens over time, no matter what's happening down below in the behavior tree. So if we start a service on attack, that service is going to fire as fast as we need it to or want it to. We can specify every second, every etc. So what we're going to do is we are going to set up a service that does the attack for us. That way the character is attacking while they're finding enemies, while they're moving to a location, whenever. While they're waiting, they can still attack. That also means that while they're running to the health or whatever, we can set it up so they're attacking. You can think of a service as a way to do something in parallel as well. You might use a service to attack, but you also might use a service to update variables, statuses, states. For example, let's say that you had random weapon drops. Every now and then you might want your AI to check for new weapons. Okay, that might be great to have as a service. You may need to check the status of their ammo. Also something you might want to check as a service. Just like with our decorators, we are going to create a new service. In this case, we just click on new service, and I am going to call this BTS for behavior tree service, and I'm going to call this attack. Now, the trick with a service is to remember that, as I said, this happens repeatedly in parallel. And so the piece that you want to make sure you do when you take a look at your overridden functions is we don't want to do this when we receive activation, because then it would only happen once. And that was actually something that we stumbled on this morning because in excitement, I just did what I always do. What we want to do is we want to trigger this on receives tick AI. So what that means is when the service gets started, it's going to be ticking, and it's going to be ticking at the rate that we specify. And that way it gives us that parallel approach. Now, as this is ticking, all we're going to do is the exact same thing we were doing in our attack. So let's go back to our attack and let's just copy all of that over into our service. So here's our behavior tree attack. I'm sorry, not behavior tree. This is our behavior tree task attack. Pretty straightforward. We can just copy this and we can paste it in here. And what we're going to do is the controlled pawn is we're going to cast that to an enemy. And if it's an enemy, what this is saying is this controlled pawn, cast it to an enemy, meaning check if it's an enemy. And if it's an enemy, because Unreal knows it's an enemy, that means you know that it has a function or an event called range attack. And so you can let me do that. That's what casting does. If you're confused by casting, you can always go back and check out our blueprint inheritance and casting video. But what this will do effectively is it will cause this range attack to happen. So let's drop our service in now. What we're going to do is right click on our sequence attack. We're going to add the service. You'll see that our new service has showed up. That is our behavior tree service attack. Okay, when we click on this service, you'll notice here over on the right, this is the interval. Let's just leave that at default for right now. What should happen, because this thing is ticking, is when it comes into this, if we are healthy and we can attack, this service is going to fire off and we're going to find an enemy, move to the enemy and wait. Then we're going to just keep doing this, but the whole time we're going to be attacking. So the way that should look is they're just attacking every second. Doesn't matter what they're doing, whether they're waiting, whether they're trying to find me, whether they're running at me, which is perfect. That's exactly what we want. Now this is a pretty tough onslaught, so that's a little bit fast, attacking every half second. You control this here in your behavior tree service over on the right in your details. Right now our interval is every half second. Let's go to 1.5 seconds. Now, you can also, actually let's go 2 seconds. And let's talk a little bit about this random deviation. By default, if I put no deviation, it is only going to attack every 2 seconds. If I change this random deviation, what that means is the timer is changed each time through. And it's changed anywhere between 0 and 1. So the attacks could happen every 2 seconds, or it could add, could be every 3 seconds, or it could subtract, it could be every second. So it's going to add this feeling of randomness to it if I want it. So if we take a look at what that looks like when we play, that was 2 seconds, 2 seconds. That was much faster, that's much faster. You can kind of see there's a little bit of randomness to the speed of the attacks. Overall, it feels a little bit slow. I think we could go down to 1 and do like a point, maybe a 0.5 deviation. I think that might feel better. Now, there's something that I want to show you though, that we need to bring back another enemy to demonstrate. We'll bring back 2 more just in case they're doing that. So they're going to be attacking each other and myself, and when they reach the 50% mark, they should run back for health. Alright, but they're attacking so fast they're not even getting a chance to run for health. We may have to slow this down. Let's slow this down. Let's go to 2 seconds on our attacks. Okay. So every 2 seconds they're going to attack. Alright, when they reach 50%, now this enemy is running, but notice they're not attacking along the way. That's because the behavior tree service runs based on the branch that it's attached to of your tree. So the only time this attack service is running is over here with our sequence it's over here with our attack, and it does not run for when we're trying to maintain our health. So as an enemy is running back to the health pack, that doesn't work. So there's a couple of solutions that we can do. What we could do is we could just take this service and run it at the top of the tree. Now, whether or not we're attacking, maintaining health, or patrolling, our character is going to attack. And you'll be able to see that here, because this time, when our characters get to 50% and start running back, notice that as they run, they're shooting out their backs to shoot at the people who are chasing them. So now our service is running all the time. However, that also means that our service is running even on patrol, which may not be what we want. So there's a couple different options here. We can change the order of our tree, we can do that, or what we could do is we could do the attack here, and we could do the attack here, and leave our patrol alone. This way they are only attacking when they are meant to attack, or when they're running for health. On patrol, they don't have either they can't attack, or maybe they haven't obtained an enemy, for example, and so they're not attacking when they're on patrol in this particular case. But that is going to depend and be determined based on how you set up your overall behavior trees as to what behaviors you want. Okay, so let's talk about a final piece. And you saw it, and this is a little bit of our stretch goal. As this character is running for health, notice how they're shooting out their backs. They're not facing the character that they're shooting at. This is actually even more prevalent or noticeable if I go down to one enemy and I change our enemy's move to target acceptance radius to be 400. What's going to happen now is when they come close, you'll notice that no matter where I am, as long as I'm within 400, they do not update their facing. And the reason is because we are not telling them to focus on the person they're shooting at. So typically speaking, or at least one way of doing this is using what is called set focus. And what I need to do really quick is reset a couple things, because at first this is not going to work. So what we're going to do is we're going to create a new task called set focus to fix this. Actually, by the way, we finished all of our primary goals, right? We are able to create custom decorators and we're able to create custom services, which is awesome. You'll be able to use those in a lot of different ways in your behavior trees. You can use them with EQS queries. Every now and then you want to check to reload, you want to check for health drops, all those things. So awesome job so far. That's great. As a result of this service, though, we've kind of uncovered a problem that's a little bit of our stretch goal to fix this setting of the focus. Now, I am going to create a new behavior tree task for setting focus. So let's do that. Over here, let's take, let's just make a new one. Okay, so we'll go with new task, and I'll duplicate. Let's do the attack. Stop. Okay, so what we're going to do is we're going to create a behavior tree task, and we're going to call this set focus. And what I want to do in here is I want to get our owner blackboard, and from that I want to get our target enemy. So let's get the blackboard thing, the blackboard key as object, and the key that we're going to be looking for, if we click on or we type make here, we're going to make a literal name. By the way, in practice, a lot of times I will make these all variables, but this is very short from the standpoint of I'm not reusing it in a bunch of places. But this name is target enemy, and we're going to take this value, and I'm going to cast this to an actor. The reason I'm doing this is because I need it to be an actor for I believe it's our controller. Let me remember this. Set focus. So we can set the focus of our controller to be a new focus. And if you mouse over this, you'll notice that the new focus is an actor object reference. So I cannot connect this object directly in. See how it's red? I know that I need to at least check to make sure this thing is an actor before I set focus. So let's go ahead and do that. And as an actor now, I can check into the focus and we can finish the execute. So this is a task that basically tells our character to focus on the target enemy if they have one. This is not going to work yet. The reason this is not going to work is because of checkboxes. Actually, these are our defaults. Actually, I don't even have this connected, so let's make sure this is connected first. So BDT set focus. Okay, so we want to, after we find an enemy, let's set our focus on the enemy, and then we can move to sure, that's fine, and wait. Now if we do this, notice what happens now when we play. They're focused on me. Now if I move around, what we want this enemy to face us. That's not working. The reason that's not working is because of a hidden checkbox. Everything, it's all about a checkbox. in our enemy on the movement component, there is, if you do a search for rotation in your details, like up here on the right, if you type in rotation, there is a movement option where you can use controller desired rotation. And I believe we also need to uncheck orient rotation and movement. Let's double check. So now they'll rotate and face us. And as I'm running around, you'll notice the character is turning to point to look at me. Now, a really good question came up in the live stream this morning about this, you know, making the character's feet move. That's a whole other can of worms. It has to do with you know, animation trees and states and kind of what's generally called turn in place. But the overall point is this character now has a focus on us, and as I run around, they maintain that focus so that when they go to shoot, it looks like they're shooting at us and not out their backs. Now, we need to test this with more than one, because this is also going to uncover a different thing. So once they get down to 50% health and they start running back, as they run back for the health, notice that they're still focused on me, not where they're running to. It's kind of weird. So we kind of need a clear focus as well. Now, again, during this morning's live stream, you all are awesome, pointing out a lot of cool stuff. We could create a clear focus. That is something we could absolutely do. Or we could set focus to be able to have a toggle. So let's just do it both ways, just for ease, just so that you can see both ways. If we duplicate set focus and we call this clear focus, this one's actually pretty straightforward. What we can do is off this pawn or off this controller, we can just type clear focus, and we can even get rid of all of this. So clearing focus can be like one of the easiest behavior tree tasks out there. So we'll go ahead and return true on this. And what we want to do is in our tree, if they're going to find health before, we could probably do this before they do the move twos in both cases. That's our attack. Before they do this move two, let's just do our clear focus. Now, this is still going to cause a problem, or it brings back an old problem, but it will at least work. So now they're shooting at whoever they're shooting at. We're going to get down to 50% health. One of them is going to run. Now, as they're running, we're back to the situation where they're shooting out their backs. And that is because as they're running, we've cleared the focus, but we're still attacking. And our attack has no concept of facing the enemy that they're attacking. So technically, to get this to work, probably the best way, the way you would want it to, is you would update attack to potentially in here face the enemy you're attacking. Now you're going to have to do some work to make sure there's enough time for them to turn and face the enemy and then return. And we'll do that here in a second. But before we do that, let's make another version of set focus that has a toggle. Okay, we are going to basically, we're going to change this set focus. We're going to create a new one. So let's duplicate set focus. I'm going to call this, just for clarity, set or clear focus. And what I'm going to do in here is the exact same thing as set focus, but I'm going to add a variable. And we can get rid of a bunch of these other ones that we don't need because these are all leftovers. Okay, what I'm going to do is I'm going to create a variable called b clear focus. And I'm going to make that instance editable, expose on spawn. And then what I'm going to do in here is I'm going to get that. And in order to test that, if I hold B and left click, I can create a branch, or I can just drag off of this and type branch, either one. I like the B left click option. So if we want to clear the focus, if that's true, what we are going to do is we are going to take our controller and we are going to clear the focus. So let's set this up like this, and also connect our false in. So, and we'll recap this here in a second. Now, if clear focus is set to true, we want to clear our focus, and then we want to finish executing. If it's false, that means we're setting the focus to our enemy target. Move this down here for clarity. To our enemy target, we're going to set our focus and finish our execute. Either way, this should be successful. So now what we can do is I can show you how that manifests itself in your behavior tree. If we go back to our behavior tree and we get rid of this set focus and we drop in our set or clear focus, you'll notice here in the top right, there is now under default a variable that says clear focus. So if I check that, it will clear the focus. If it's unchecked, it will focus it on the current target. So in this case, I can get rid of clear focus. I can basically have one behavior tree task that does both of these. And in this case, I would just check this box. So now we should be back to the exact same behavior where they're focused on their targets, but as they run for the health, once they get down to 50%, they'll clear their focus and they'll run and actually face where they're running. They still have the problem where they're basically shooting out their back. So a way to fix that, as I had mentioned before, was in this behavior tree service of attack. Before we do our ranged attack, what we could do is we could focus, set the focus here and clear the focus with some delays. There's some tricks to that. I'm going to go ahead and show you how to do that just so that you can see it. Let's get our controller or our blackboard. Let's get our blackboard. And we're going to get our enemy, our target enemy. So we're going to get a value as an object. We'll just do this. And I could just copy paste this, but repetition's good. So let's go target enemy in this case. And as a target enemy, let's cast that to an actor. We could also set our target enemy to be a default class of actor in the blackboard, so we don't have to do this as well. All right, and what I'm going to do is, if that's successful, I am going to take our controller and I'm going to set the focus to be our target enemy. And then, once I have set that focus to be the target enemy, let me just clean up these lines a little bit. What I'm going to do is I'm actually going to do a delay. This is the part I don't like about this. I don't like having the delay in here. I would probably, there's something about delays in some of these spots that give me a little bit of the heebie-jeebies. Doesn't mean it's wrong. It just means I would probably try this using maybe a sequence in a behavior tree instead or something like that. There's just something about delays could get messy later, but this will show you the problem, which is good. So there'll be a delay. It's going to turn and face, and it's going to attack. And then after the attack, I'm going to delay again. And then what I'm going to do is I'm going to clear the focus. Now after the attack, when I clear the focus, I don't want the delay to be quite as long. Let's go, let's try 0.5 on these delays. Oops, I double clicked so we get some C++. Let's go back to our project. Here we go. We go 0.5. Great. Now, so we now have our attack. Now we'll go ahead and use delays, face who they're attacking, and so on. So we can go back to our behavior tree. We do not actually even need to set this focus here for these attacks. We could probably even get rid of this one here. Let's see if this works. Okay, so they're facing me, they're attacking, they're facing each other, they're attacking. That's great. Now, what's going to happen is when they start running, you'll notice the difference. We need somebody at 50. So they're running, they turn back, they turn back. So you can see that they're at least turning to face me to attack and then turning back to continue. But you can also see the problem with that, where they're running while they're still running, because in here this move 2 is happening. So you'd have to get a little bit more specific about the behavior. Mid-run, if they're going to attack, they need to pause for a second and go through that. But you have created successfully your own custom behavior tree decorator used to help you make conditions for whether or not you should evaluate branches within your behavior tree. We've also talked about our behavior tree services, which is basically, it gives you a way to do tasks in parallel, or do something in parallel to what's running in the behavior tree, which is really cool. Great for things like attacking or checking for new weapons or new items or whatever you want your enemies to be able to do. Also, we hit a little bit of our stretch goal, and I wanted to kind of forward think a little bit that something that is going to potentially come up for you is, as you're running around, why is my character not facing the way I expect them to be facing? It's because of a checkbox. So there's more than one way to get that particular thing to work, just like in Unreal, there's more than one way to do a lot of different things. But you know, at least hopefully knowing about that checkbox maybe will be in the back of your mind when you do get to that point. As always, thanks for checking out this video. If you like what you're doing, help spread the word. Keep an eye out for upcoming videos. We've got Anim blueprints coming. We have two new arrays and for loop supply videos coming that deal with sorting information as well. That should be a lot of fun. And as always, all feedback welcome. Throw it down in the comments. Hop in Discord. Let me know what we're doing, the types of things that you would like to be working on, and we will go from there. So, as always, thanks for checking out the video. My name's Kevin. We'll see you in the next live stream. Later.